Hello, we're on to lesson 2.2, which is on the limit of a function. In this lesson, we're going to be learning about limits, and limits are actually a really important foundational concept for you to understand, not just for learning how to take the derivative, but you'll be using this and revisiting this concept throughout Calculus 1 and Calculus 2. So there are actually three ways to find limits, and in this lesson you covered two of those, which is finding them graphically or using the graph and numerically. Hopefully you viewed this video. I find this video one of the best for trying to explain the idea of limits. A lot of times if you look at it mathematically, it's a little more difficult, but when you see this video, it's very good. So if you haven't visited this video, please do so. All right, so hopefully that video gave you a good idea of what the limit is conceptually. So let's just make sure that we understand together. So let's look at these two examples. We want to find the limit as x approaches 2. So again, we want to look at what's happening from the left side and right side of this function, and we're not so concerned about what's actually what happens exactly at 2, but we're concerned about what's happening as we approach 2. So approaching from the left side, or we often call that the negative side, so the limit as x approaches 2 from the negative side, it's approaching the value of 4, okay? And again, it doesn't matter that the 4 is not filled in, that there's not actually a point there. We're only concerned about what it's approaching. And from the positive side, which we denote this way, it's also approaching 4. So we can say that the limit as x approaches 2 of f of x is equal to 4. All right? And what about at 3? Okay? Again, as we're approaching 3 from the left side and the right side, we're looking at what the y values are approaching. And it just happens in this case that this point is actually filled in. There are no breaks there. But we don't really care if there were a break, okay? Really, it's just a matter of looking at what it's approaching. And if you look at the y value here, it's approaching a y value of 3. All right, so hopefully you learned the two different approaches to finding limits in this lesson. The first one was to plug in numbers or find it numerically. The second one is to look at the graph, and that's what we just did in the last slide, is we looked at the graph to determine what the limit was. And hopefully you looked at the videos to find some examples of how to determine limits numerically and to get some practice. This is actually a really great way to find limits because oftentimes if you can't solve it algebraically, which we'll learn about in a new lesson, and you maybe don't have your calculator, your graphing calculator, what you can do is you can plug in values that are very, very close to the x value for which you're trying to find the limit. And get your answer that way. So you can always depend on this method. All right, so this is your first set of try this problems. We're going to use numerical methods to find these limits, and it doesn't actually use the language of limits in these slides, but it's meaning the same thing. We're looking at the function and how it behaves as x approaches a given value. And so that's what limits are. So let's look at the first example. We have, how does f of x equals x plus 2 behave as x approaches 3? So what I typically do is I draw a table. And I put my x value here and my f of x value here. And then what I do is I put the number that we're trying to find the limit at. And so in this case, we're looking at 3. And so I look at numbers that are slightly less than 3 and numbers that are slightly greater than 3. And so I can go ahead and plug in, excuse me, this should have been, let's look at 2.9, and let's look at 2.99. And we're looking to get really close to 3, so 2.999. And then numbers that are slightly bigger than 3, so 3.001, and how about 3.01, and then let's say 3.1. And so we plug those into the function, and then we get values for those, and we can see what the function is, how it's behaving, or what the limit approaches as x approaches 3. So if I plug 2.9 into that first function, that's very easy to calculate. We can even do that in our heads. We're going to get 4.9, correct? And then if I plug in 2.99, I'm going to get 4.99. If I plug in 2.999, I'm going to get 4.999, and so on. Again, we're not worried what's happening exactly at 3. If I plug in 3.1, I'm going to have 5.1. If I plug in 3.01, I'm going to do 5.01. And if I plug in 3.001, I'm going to have 5.001. And we can see that the limit is approached, these values here on the left side, 4.999, that's approaching 5, and 5.001, those values are also approaching 5. So we can say that the limit as x approaches 3 of f of x is equal to 5. All right, so let's try the next one together. If we have x here, and our function is f of x equals sine x, and the value is pi over 2, which you'll want to make sure you're trying to get really close to pi over 2, so you don't want to use measures like pi over 3 or anything like that. You'll want to convert that to a decimal place. So pi, if I take pi and I divide it by 2, I get the value 1.5708. Let's say that, okay? 1.5708. That is pi divided by 2. So we're going to pick values that are close to that on both sides of it, all right? So I could try on the left side of it, so slightly less than, I could do 1.5, let's do 1.57, zero, and we could do 1.5 or 1.55. It doesn't really matter. You're just trying to see the trends as we get close to this. And on this side of 1.5708, I'm going to pick something like 1.571, 1.57, let's say 5. That should be enough, okay? So we're getting super close to 1.5708. And then you just find them in your calculator. So in this case, if I take 1.55, and you want to make sure that your calculator is in radian modes, or in radian mode, because otherwise you're going to get the wrong answer. So 1.55, and I take the sine of that, again, be in radian mode, I'm going to get 0.9997. Or actually, if I round, it's 1.9998. And then what if I did 1.57 and took the sine of that? Ooh, I'd have several nines, so I get 0.99999. So I get 6 nines. All right. And then 7. And then let's try, it looks to me like those values are approaching 1, doesn't it? And let's try 1.571, 1.571. We take the sine of that. Again, we have 7 nines in this case, and then an 8. So on this side, we have 7 nines, and then an 8. And we probably don't even need to look at this value, but you can see that these values are getting closer and closer to 1 from both the negative side and the positive side. So we could say that the limit as x approaches pi over 2 of sine of x is 1. All right, let's look at the third one. The third one is sine of x over x. And we want to find out what happens when x approaches 0. So we take numbers just on the left of 0. Let's do negative 0.01, negative 0.1. And actually, I'm going to erase that for a second. Let's do one more. Negative 0.001. And then we have 0. And on this side, let's do 0.001, 0.01. And let's see what happens. So again, you want to have your calculator in radians mode. And if I take, I'm going to look at this value and this value. I'm not going to do that 0.1 value. And then on the positive side, I'm going to do this value and this value. All right. So if I plug in negative 0.01 and I find the sign of that and then divide it by 0.01 negative, I get 0.999, 4 nines and an 8. So 0.99998. And then if I do the same thing for negative 0.001, I get, now I have 6 nines and an 8. 5, 6, and an 8. Okay, now let's jump to the positive side. I do 0.01, take the sign of that, and divide it by 0.01. I get 4 nines and an 8 again. 0.9999 and 8. And I'm guessing that if you did 0.001, you're going to get the same value as you did for negative 0.001. But let's just make sure, 0.001, take the sign of that, and then divide it by 0.001, and you get 6 nines and an 8, yes. So we get the same value, 0.9999998. All right, so what does it look like that the function is approaching as x approaches 0? It looks like it is approaching 1 as well. All right, so these are some videos that you watched hopefully to figure out how to determine the limit by looking at graphs. And in these videos, we had things about unbounded limits and talking about one-sided limits as well. So let's go to the try this problems in the next slide and see if we can't look at those. So let's look at these problems. The first problem, the limit as x approaches 1. Here's the value of 1 on the graph. And this is similar to the problem that we saw in that initial slide when we looked at the two examples. The limit as x approaches 2 and the limit as x approaches 3. There's no hole here, and so we can just look at what this graph is approaching. And it looks like it's about 1, doesn't it? All right, so this answer is 1. All right, how about at negative 5? So let's find negative 5 on the graph. Here's negative 1, negative 2, negative 4, negative 5. So we're looking at the graph as x approaches negative 5 from the left. Let me make that a little neater. From the left side and from the right side. All right? And it doesn't matter, again, that there's a hole there. We're only concerned about what it's approaching. So from both sides, it appears to be approaching a y value of about 2. Now, if I had asked you what f of negative 5 was, okay, so let's go up here and make a little note. If I had asked you what f of negative 5 was, your answer would have been actually 1 because the actual value is at 1. But we were looking at the limit as x approaches negative 5. All right, let's look at the limit as x approaches 2. Okay, so we're finding 2 on the graph. And this time, we're looking at what's happening as x approaches 2. And so from the left side or the negative side, all right, the limit as x approaches 2 from the negative side is going to be, it's approaching the y value of 1, isn't it? All right, and what about from the right side? From the right side, we look at this portion of the graph, so coming on the right side, and it's approaching negative 1. So do you see that those two, the limit from the left side and the right side, they're approaching different numbers, and so they're the limit is not, their limits are not equal, so we have to say that the limit as x approaches 2 of f of x does not exist. All right, and finally on the fourth problem, we're looking at negative 3. So we look at this portion of the graph right here, And from the left side, it's approaching positive infinity. And from the right side, it's approaching positive infinity. So the answer here is positive infinity. All right, let's look at these try this problems. And I'm going to go through them one at a time on the following slides. So before I get into this first problem, it's worth introducing the tool that I used for these problems and that I'll use frequently throughout the course, and that's called the Desmos Graphing Calculator. And you can get this calculator on your smartphone, or you can get it on your computer just by visiting the URL, which is desmos.com. And when you get to the calculator, you just enter your equation that you're trying to graph, and it'll graph it there for you. So y equals 3 is just this horizontal line, as you recall, probably from algebra and pre-calculus. It's a horizontal line. And so when I take the limit as x approaches 5 of 3, here's my value 5. I'm approaching from the left side and the right side. And from both sides, we're just approaching an output or a y value of 3. All right, on the second problem, we were trying to find the limit as x approaches 2 of 7x minus 4. So I've graphed y equals 7x minus 4. And I'm looking at the limit as x approaches 2. So here's 2, and we're approaching from the left side and the right side. And if you look from both sides, the graph is approaching the y value of 10. So in this problem, I also want you to note that if I ask you to find f of 2 and you plugged 2 into this function, you would get 14 minus 4, which is equal to 10, right? And so when the limit actually equals the value of the function at that point, we have a special name for that, and that name is continuous. All right, and we won't talk about that anymore this lesson, but we'll introduce that in a future lesson. All right, let's take a look at the next problem. And we have the limit as x approaches 0 of 1 over x. So let's find 0 on the graph. There it is. And we want to approach from the negative side. And when we approach from the negative side, do you see how the graph is shooting off to negative infinity? It's getting infinitely negative. And from the positive side, what's happening? It's going to positive infinity, right? So if I wrote the limit as x approaches 0 from the negative side of this, my answer would be negative infinity. And if I asked you to find the limit as x approaches 0 from the positive side, you would say it's positive infinity. But since those two are not equal, we have to say that the limit as x approaches 0 of 1 over x does not exist. For this next problem, we're taking the limit as x approaches 0 of sine of 5x over x. All right, so as we're getting closer and closer to 0, here's 0, from the left side, it appears that we're approaching the value of 5, and from the right side as well. So if we look at the graph, we can see that the limit is 5. Just to confirm our answer, let's look at this numerically as well. So if you look at your graphing calculator, there's an icon at the top that looks like this. And if you click on that, it'll give you the option to pull up a table. And the table pulls up these values, x values, and their outputs as well. And it self-generates some values, and they're not very close to the value of 0. So if you're looking at limits, you actually need to change those values to become very close to the value of 0. All right? And if we do so, we see that as we get close to 0, our y values are getting close to 5. So this just confirms what we saw in the graph. So in this next problem, we're looking at the limit as x approaches 1 of x squared minus 1 over x minus 1. And so as we get close to the value of 1 from the left side and the right side, the limit is approaching 2. Looks pretty straightforward. What's interesting about this graph is that it's a bit misleading, okay? If you look at the values on the table, you can see that x equals 1, the function is undefined. So if you were to zoom in on this graph, you would see a hole at x equals 1. Now, does that affect the limit? No, it does not affect the limit, but it does affect the continuity, which we talked about briefly in the last slide. So just wanted to make you aware that sometimes the graphs are a little bit misleading. I also wanted to make note of the fact that this was the self-generated table of values that I pulled up when I looked at this function, and notice that if you're not adequately close to 1, the values are not going to show you what the limit is. Now, if you put your own values in, though, and make them very close to 1, all right, you're going to see that the value of the function is approaching 2, which is the limit that we identified on the picture of the graph. I really just wanted to make you aware of a couple of things. As you use your graphing calculator, sometimes it can be a little bit misleading, and also the importance of picking values that are very, very close, very close to the value that you want to find the limit at. So this last problem is a piecewise function, and hopefully you recall how to graph piecewise functions from your pre-calculus days, but you can also use this Desmos tool. And it's a bit tricky to enter, but you can Google it and ask Google how to enter a piecewise function on Desmos. It will show you. But basically, you're entering the domain and how the function is defined on that domain, like this. So for x less than 2, the function is defined as x plus 1. And then you put a comma, and then for x greater than or equal to 2, it's defined as x squared minus 4. All right? And so this x plus 1 corresponds to this section of the graph, and x squared minus 4 corresponds to this section of the graph. And we want to find the limit as x approaches 2 from the negative side of f of x. And we also want to find the limit as x approaches 2 from the positive side of f of x. So with piecewise functions, from the negative side, that corresponds to this portion of the graph, and here's our 2, but it's approaching from 2 from the negative side. It's approaching the y value of 3, it looks like. And from the positive side, that corresponds to this portion of the graph, and as we're approaching 2, the graph is approaching the value of 0. And we call these one-sided limits. All right, so the limit as x approaches 2 from the negative side is 3, and the limit as x approaches 2 from the positive side equals 0. Once again, if I asked you what the limit as x approaches 2 of f of x is, since these two values do not equal one another, we have to say it does not exist.